In this vodcast, we're going to talk about noble gas notation and valence electrons. Noble gas notation is the shortcut for doing orbital notation and electron configuration notations. First thing you need to know is where the noble gases are on the periodic table. So if you look in group 18, you'll see the noble gases. Helium, neon, argon, krypton, xenon, and radon would be all of your noble gases. So if we wanted to do the noble gas notation for aluminum, what we would do is backtrack until we hit a noble gas, and the noble gas we find is neon. So again, we're going to start with aluminum. We backtrack until we hit a noble gas, so we go backwards. The noble gas we run into is neon, so we put neon in brackets, and then we do the configuration from neon up to aluminum. So I put neon in brackets, and then I would do 3s2, 3p1, 3s2, 3p1. And that's the shortcut way for doing aluminum. What we assume when we write neon in brackets is that's the configuration covering the first two rows of the periodic table. What we really want to see is the configuration for the row or the energy level that that element is in. So let's try another one. Let's just say we're going to do the noble gas notation for, how about copper? And then we'll do the noble gas notation for calcium. So let's do copper first. Alright, for copper, we would backtrack until we hit a noble gas. The noble gas we hit is argon. So I write argon in brackets, and then I do the configuration from argon up to copper. So after argon comes 4s2, 3d10, excuse me, that wouldn't be 4s2, 3d10, that would be 4s2, 3d9, because copper is the second last element in the 3d sublevel. If we were going to do the noble gas notation for calcium, we would backtrack until we hit argon and put argon in brackets. The configuration from argon to calcium is simply 4s2. So as you can see, you're using the noble gas, and then you're only doing the configuration really for the row that that element lies in. Let's try one more. How about we do thallium. Thallium is TL, and it's number 81 on the periodic table. So if I backtrack from thallium, I'm going to put xenon in brackets. Then after xenon comes 6s2, 4f14, 6s2, then 4f14, 5d10, and 6p1. So again, you can see I backtrack till I hit a noble gas, and then I do the configuration from that noble gas up to the element. So 6s2, 4f14, 5d10, 6p1. Now if we want to talk about valence electrons, valence electrons are the electrons in the outermost energy level. So the electrons in the outermost energy level of an atom. So if we want to look at our outermost energy level electrons, the noble gas notation is an easy way to do that. If we look at aluminum, the outermost energy level that has electrons is the third energy level. And aluminum has 2 plus 1, 3 electrons in the third energy level, so we would say that aluminum has 3 valence electrons. For copper, the outermost energy level would be the fourth. The reason we don't include this one is because the fourth energy level is a higher energy level than the third energy level, so we only count the electrons in the fourth energy level, and we would say that there are 2 electrons in the outermost energy level for copper, so 2 valence electrons. For calcium, It's the fourth energy level is the outermost energy level, and that has 2 valence electrons. For thallium, our outermost energy level would be the sixth energy level. So just like we did over here with aluminum when we looked at the S's and P's, for thallium we have to look at the S's and P's as well. So 2 in the S, 1 in the P, that's a total of 3 valence electrons. So one thing that you might notice from this is that valence electrons only come from the S and the P sublevels. They're never going to come from the D sublevels because the D's are always going to be 1 energy level behind, and they're never going to come from the F sublevels because the F's are always going to be 2 energy levels behind. So never the D's and never the F's. Valence electrons only come from the S's and P's. So if I asked you the question, what's the most number of valence electrons an atom can have? Well, you would think to yourself, okay, the most that an S sublevel can hold is 2 electrons. The most that a P sublevel can hold is 6 electrons. So that's a total of 8 valence electrons that's possible. And that's what all of our noble gases except helium have. They all have 8 valence electrons. The other thing to point out is that elements in the same column are going to have the same number of valence electrons. So if you look at aluminum and thallium, they're in the same column on the periodic table, and if you notice, they both have 3 valence electrons. Everything in the first group is going to have 1 valence electron because it's going to end S1. Everything in the second group is going to have 2 valence electrons. Everything in group 13 is going to have 3 valence electrons, 4, 5, 6, 7, and 8, with the exception of helium. So those are just some patterns to notice when we're talking about noble gas notation and valence electrons.